The last thing I wanted to talk about in terms of sensation and perception is auditory development. This one's a little bit shorter because, I don't know, I think hearing, I don't know. It's not that it's not important, but I think as far as components, it's a little bit simpler. But hearing, this is the anatomy picture that I wanted to show you guys. Hearing is going to involve both the external, well, not both, all external, middle, oh my god, words are hard, middle and inner ear, specifically the cochlear part of the inner ear. So remember I told you the vestibular system is made up of the semicircular canals, so you can see they're all pointing in different directions. They're filled with fluid, and they have different hair cells that are going to float and change direction based on how the fluid moves, right, which will tell us our orientation of our head in relation to our body, or how fast our head is moving in relation to our body. So that's the vestibular part, which we talked about is kind of an important role in kinesthetic sensation and perception. The other part of the inner ear is the cochlea, which also has hair cells and also has like this fluid-filled snail shell type shape. But this is going to be responsive to sound waves. So as sound is occurring outside, right, our external ear and the shapes that we have of this external ear are going to kind of trap these sound waves, push them down the ear canal, and then they hit the eardrum, which is in the middle ear, right? And then we have 3 little bones. I don't know if you guys remember the names of those. But anyways, there's 3 bones that are going to vibrate in response to the sound waves that we pick up. And then those vibrations are going to cause fluid to move inside the cochlea. And then that's going to cause hair cells to shift. And those hair cells moving send information through our cochlear nerve, which goes back to the brain. And then we're able to kind of translate that auditory sensation that we get from these hair cells moving to an interpretation or auditory perception of sound. Okay, so hearing is going to involve all of these different parts of the ear, specifically the inner cochlear part of the ear. That's where the actual receptors are. Everything else is just kind of like a sound wave transduction pathway to get to the sensory receptors. So anatomical structures are mostly developed by the second trimester, which means that when babies are born, their hearing is pretty much what it is, okay? Actually being able to identify sounds, that's a different situation. But terminology-wise, there are 2 different types of thresholds we have to talk about. One is an absolute threshold, so this is the minimal detectable sound a hearer can detect half the time the sound is made. Differential threshold is when you are looking at 2 sounds, okay? So it's the closest 2 sounds can be together, but still be distinguished by the hearer at least 75% of the time the sounds are made. So if I gave you a tone, and then I gave you another tone, and then I kept making the tones more similar and more similar, the differential threshold is at what point are you still able to distinguish that there are 2 sounds being played. So it's kind of like the auditory equivalent of a 2-point discrimination for a kinesthetic sensation test. When we look at different stages of hearing, infant hearing, usually there's gelatinous tissue filling in the inner ear, and they are able to hear about 60 decibels higher than adults. So maybe first what I should say is, what is the difference between decibels and hertz? So we have this chart to the right, and we have loudness expressed in decibels. So loud being at the very, very bottom, soft being at the top. So we have like rustling leaves versus an airplane or a chainsaw. And then we have pitch, which is expressed in hertz. Low pitches are lower tones. Okay, higher pitches are higher tones. So you can think of if you were in choir, right? Sopranos sing higher pitches than bass, which sing lower pitches. But we can have different pitches occurring at different decibels or different levels of loudness. So Infants' hearing is about 60 decibels higher than adults. So they can hear softer tones, if we think about it in terms of loudness, which is why they are so sensitive, and it's so easy to wake up a baby, right? Because they are very, very sensitive to these soft loudness levels. By 3 months, they're able to detect low frequency sounds, around 500 to 1,000 hertz. So if you look in pitch, okay, these low frequency, mid-range area here, they're able to pick up, right, low frequency sounds, but not usually any frequencies higher than 4,000. So anything above 4,000 is like our cutoff at 3 months. But by 6 months, hearing is pretty similar to that of adults. So remember I was saying that pretty much when you're born, your hearing is what it is. The only reason it's different, because, I mean, your ears are an orifice to the inside of your body, so there are different protective mechanisms in fetal stages that will kind of protect the ear from filling up with fluid. And as those anatomical changes adjust, right, our hearing is going to adjust. But this blue range in this picture is typically where adult hearing is. Shh. Cat. Older adult hearing, there are some problems that can happen as you age. We call one of these presbycusis, which is the loss of hearing from physiological damage or exposure to environmental noise, also known as old man hearing. Actually, I think that's the exact translation of presbycusis, but it's just the natural loss of hearing that comes with age. Causes could be physiological damage. So if you have nerve damage or one of the structures in your ear, like if your eardrum got punctured or something along those lines, that could be one reason why presbycusis happens, and that could be due to either trauma or just natural aging of tissues. But it also could be exposure to environmental noise that damage the hair cells. And once hair cells are damaged, they do not regenerate. So if you listen to super, super loud music all the time, and you're not protecting your ears, then that could also cause hearing loss. Also, if any of you have ever had or experienced tinnitus, which is like a ringing in your ears, that is not necessarily always attached to older adult hearing, but that could be if you know, like, what do you call them? War veterans, right? If they're exposed to loud explosions, they could end up with tinnitus from that kind of acute traumatic exposure. Absolute and differential thresholds increase. So remember we said that absolute thresholds is the minimal detectable sound that a person could hear. Differential thresholds are being able to distinguish between two sounds. Those thresholds are going to increase or worsen with age. But usually that means that we either need louder volume in order to be able to distinguish sounds. So softer volumes, that's why usually when you have older people, you end up yelling at them or talking a lot slower. Just because those thresholds are increasing. So also their ability to hear high frequencies decreases. So the lower your voice is in pitch, the more clear it is perceived by an individual who is older, at least. All right, and then we have auditory location. So this is again part of our perception. How do we take the sound waves through our ear, we can sense them in our temporal lobe, and then what do we do with that? Where is the sound coming from? So location is determined by direction and distance from the individual. Adults can usually distinguish sounds that are about 1 to 2 degrees from each other, which is pretty impressive, right? If we look at these lines and we move from this location to 1 to 2 degrees away, they're able to distinguish that those sounds are coming from 2 different locations. Around 6 to 7 months, that distance discrimination is 12 to 19 degrees, so not as acute in little babies. By age 3, you have a fairly accurate ability to locate near and distant sounds as well as direction. So if we had this red dot and it was closer to us, we would still be able to distinguish that sound was closer versus further away by about age 3, compared to direction, which we might have a sound from right in front of us to a sound to the side of us. Okay. Older adults with presbycusis have trouble with sound location. So just, like overall auditory acuity is decreased, and that's going to have an impact on our ability to locate where sound is traveling from. There are differences in sounds, or being able to recognize differences in sounds. So age 1 to 4 months, so infancy. Usually babies are able to discriminate basic speech sounds. So you guys saw on this one, there's different letters that are within this blue range. And if you notice, a lot of these are kind of between that 500 and 1,000, right? Or technically 5,000 and 5,000. 500 and 4,000. A lot of those speech sounds are kind of in this area. So that pretty closely aligns with this 1 to 4 months. I think that was a 3-month frequency range. So most speech sounds are able to be discriminated pretty early on. And then by 8 to 10, we have a general ability to detect differences in similar sounds. And then mid-adolescence, we have this refined ability. So it just gets better with age. Okay, but that's a lot of times you'll hear younger children mispronounce words, and that's just because they can't distinguish that part of a word is actually different than how they're pronouncing it. There are also patterns with regards to the properties of sound, so time, intensity, and frequency. Temporal changes actually are the first characteristics to be recognized by young infants, and so the temporal changes being time, but we relatively have a refined ability to recognize different auditory patterns and relationships of tones and intensities by about 12 months. So if you think about this in terms of music, right, we kind of can get a general timing of when pitches are announced, or when pitches are given, right, the intensity of those pitches, or I think loudness could also be related to intensity, and then also the frequency and how fast we have sounds being presented to us, right? So again, pretty refined ability to recognize sound patterns by 12, but by 12 months, we're a year old, but differences in sounds takes a little bit longer to fully develop. Auditory figure and ground. This is the ability to focus your attention on specific sounds amongst other relevant sounds. So young infants, usually they have ambient background noise, right? Or that's kind of what they hear. Some individuals between childhood to adulthood have a hard time kind of focusing their attention on specific sounds. And then older adults usually have a problem separating certain sounds from background noise. So again, this ability kind of progresses as we go. But if you've ever been in like a club or a party or family gathering and you were trying to talk on the phone with loud noises going on in the background, sometimes it's hard to focus on what a person is saying. I think the auditory figure and ground concept generally is going to also have an attention component, so attentional focus specifically, and how you're allocating different components of your attention or your attentional capacity to different objects, either towards the figure or the specific sound that you have amongst the ground noise or the irrelevant sounds. So I think changes in age could either be due to attentional changes or changes in the hearing system. And last but not least, let's talk about intermodal perception, or kind of the interrelationships between different types of sensations and perceptions. We use and integrate a lot of our modalities to influence how we perceive the environment. And I think this is most apparent in the examples I was giving you guys in terms of when we test kinesthetic awareness and we make sure that the eyes are closed, because two of those systems working together can give us a lot more information than if only one system is working at a time. So there's two primary perspectives on how we have intermodal perception. One is that we have the integration perspective, where infants are going to develop abilities to integrate separate perceptual systems. And then we also have the unified perspective, which says that perceptual systems work as one unit to recognize patterns about the environment. So one, we're saying that different body systems are going to develop independent from each other, and then eventually we're able to integrate the development of each of those together. The other one says that each relies on the development of the other, and they grow together as one unit. But we have different modality pairs: auditory visual, visual kinesthetic, auditory kinesthetic, and spatial temporal. Okay. Auditory visual is being able, usually I'll just kind of describe how we test these, but auditory visual, usually a sound is played and you have to locate where the sound is with your eyes, or you hear a sound and then maybe you watch a video and you're able to match the correct audio track to the object making the sound. So maybe someone plays a bird chirping and then you watch a video and there's a bird chirping and then you're like, oh, the bird's making that noise, right? You're able to match visually what auditory sensation you're hearing or how you're perceiving the auditory sensation. Visual kinesthetic pair is looking at coordination between seen and felt properties of objects. So typically this is the difficulty. Difficulty exists in this type of perception if the initial exposure to the if you have initial exposure to the kinesthetic experience only. So if someone gave a person a teddy bear and was like, what is this? Without having a visual representation matched with the kinesthetic perception initially, it's kind of hard for them to distinguish, right? If any of you have taken anatomy at Long Beach, there's a classic visual kinesthetic test that you actually are exposed to in one of your first lab practicals, which is the bone in the box. And you have a bone stuck in a box, you can't see it, but you're supposed to feel it, right? And be able to identify it based on the landmarks that and the shape that you feel. But usually in labs, we know that we visually can see what bones look like. We're able to manipulate them, right? So having that active manipulation with the visual component is going to be more effective for fostering recognition of items based on the kinesthetic form alone. But these two very, very, very much go together. Auditory kinesthetic is where you might hear a description of a shape or an object and then try to identify it by feeling various objects. So if I gave you guys a coffee cup or a mug, and I if I verbally described like, oh, this is made out of glass, it's a cylinder with a hollow center and kind of a half ovular arc shape on the side, on one side of the object, right? You'd be able to feel that, and then you might be able to recognize that that is a cup based on how it feels. Or if I gave you a bunch of objects, you would be able to pick out that object without vision, right? Just based on how I described the object. So that would be an example of auditory kinesthetic. And then lastly, we have spatial temporal. So this is between space and time. Integration of temporal patterns is a little bit more difficult than integrating spatial patterns. So replicating a rhythm is harder than replicating the general sense of a movement, if you want to think about it that way. Difficult or subtle aspects can continue to develop into adolescence in terms of how we are able to utilize intermodal perception. It's likely stable in adulthood and older adulthood, but again, there's some limited research in these areas. And decrements are likely due to functional changes that decrease the acuity of sensation. Or decrements could be due if compensatory mechanisms are or are not available, right? So we talked about different ways that aging of systems could affect our perception and sensation. Usually all of those are related to a decrease in acuity. If we have a decrease in acuity, then we have kind of deficits in the system as a whole. Okay, and that's all I have for you guys on perception and sensation. It is a lot, but in the next video, we're going to relate all of this information to how we translate perception into action.